Hello everyone, this is Mainak and you're watching Civil Pro. So this is the episode 2 of the building design using Etabs. In the first episode, we had done about the basics about the modeling. We had modeled the building, and if you ever watch this video, you can go in the playlist and watch that. And today, what we'll do today, we will just look further into the loading part. Basically, we're going to cover I know the dead loads and the live loads. So what we're going to do first of all, we're going to assign the loads in the ETABS, and after that we're going to show how and why these loads are taken. Because as I always say that when you are learning a particular software like ETABS, you're not learning the software, you are learning how to design using that software, which covers all the basic aspects of your civil engineering. Okay, so I'll just quickly share the screen and show you the loads which I'm going to take right now. The dead loads as per IS 875 part 1, the three types of loads which we can generally take. There is a self weight, but the software here assigns the self weight automatically, so we don't need that. And next is the wall load. So wall load we are going to calculate and we're going to provide it on the beams. So for the 10-inch wall, there will be 14 kilonewton per meter, 5-inch wall, 7 kilonewton per meter. For the 10-inch parapet wall, that is a 1 meter height, it will be 5 kilonewton per meter. How this is calculated, these are calculated, I'll just show you in the end part of the video. Okay, and then this floor finish, we are going to take floor finish generally of tiles, marble, or a normal CC flooring, whatever you are taking. So we'll take this as 1 kilonewton per meter, and the live load as per IS 875 part 2, we're going to take here live load of 2 kilonewton per meter square. This is a mistake, so it will be 2 kilonewton per meter square. So these we are going to put. Okay, so let's open the software which we had done it till now. First of all, we'll be assigning the wall loads. So the self weight is already assigned. So what we'll do, we'll make the plinth level as our master story, and then we'll select all the beams, up to this much, this levels, and this this is the first floor roof. Up to the first floor roof we'll select, and then we'll just assign all this as the outer wall load. We're going to quickly go here, go to edit, and go to this options of your we have this edit stories and grid system, modify stories, and plinth level. We'll just make this as master story and this as no. Okay, so now what will happen is this should be no, and what will happen, so this will be similar to plinth, and this can be similar to plinth as well. So the top will keep as none because top the loading will be separate. So we'll just what we'll do, just click on OK, and we'll just click on refresh view and OK. So now what we're going to do is we're going to go to plinth view. So we're going to select here, left click, and then this, when this gets activated, we'll just go here, this first floor roof, second floor roof, this foundation level, and then the plinth level. So in the particular plinth level, what we'll do, we'll select one beam, and before that we'll just do here similar stories. So if you select one beam here, and all the beams up to this much, 1 2 3 stories are selected. So we'll do here like this. Don't have to press control in Etabs, automatically the software will take it like this, just like AutoCAD. Don't have to press the control or shift key. So as you can see, all the outer walls have been selected here up to this plinth level, ground floor slab, first floor slab. Now we'll just go to assign, and what we're going to do is we'll go to frame loads, distributed, and in here dead, and the gravity means it is going up, coming from top to bottom, and after that we'll have to assign a load of 14 and click on OK. So you can see it in the here as well. So this is a plan view. You can see 14 kilonewton load has been assigned here, and you go top here in the ground floor roof, 14 kilonewton has been assigned. In the first floor as well, 14 kilonewton has been assigned, but in the topmost floor, there is a terrace, no loads have been assigned. So our aim has been successful. So we'll go back to the plinth level and we'll select all the inner beams, and this time also we'll make sure the similar story is selected. So while selecting, so as you can see here, the similar story is already selected. That's why when I'm selecting this these things are also displayed. So I'll select them one by one, all the inner members, and when all the inner members are selected, and after that I'll go to assign, and frame loads distributed, and we'll go here and take a load of 7 and then click on OK. So the 7 was also been applied to all the levels. We'll just go here and check in this. Now in this particular view, the top, the terrace level, we'll go to the terrace level, select this again, and we'll go back to the terrace level, second or the second floor roof. So in the second floor roof, what we'll do, we'll just select this, perimeter or the outer walls. The parapet wall is basically given the terrace so that anyone doesn't fall or any accident doesn't occur. So this is a parapet wall span I have selected, and we'll go to assign and go to this frame loads distributed, and then give a load of 5 kilonewton per meter. Okay, and this 5 kilonewton per meter loads have been assigned. 5 kilonewton load is assigned on this particular terrace portion as well. So once we are done with this, we can go and assign our floor finish. So floor finish load, what we'll do, we'll select the floor finish load and give a floor finish load of 1 kilonewton per meter square, that is on the slabs. We'll go to select and we'll select all the floors. So we'll go to this object type, and in this object type we can select our floors. So you need not apply it on the plinth level, because in the plinth level load will directly go to the transfer the ground. There is no slab, so we'll only apply into this floor finish in the remaining floors. Okay, so we have selected all the floors, and we're going to apply the floor finish load. And what we're going to do is we're going to go to this assign option, and we'll go to this option of shell load. And in this shell load, we're going to just take a uniform load of in the form of a dead load gravity of 1 kilonewton per meter square, and then click on OK. In this second floor roof, I will check this. Let's see here, and we will check here 1 kilonewton load have been assigned in this. So in the all the remaining floors as well, the plinth level, foundation level, it won't be there. Plinth view also, it won't be there. In the ground floor roof, as you can see, 1 kilonewton load have been applied here. So our thing has worked. So now next thing is for the live loads. So for the live load, let's go and assign the live loads. So for assigning the live loads, what we'll do, we'll go and select all the floors, and we'll assign a live load of 2 kilonewton per meter square in all the floors. So we'll go to select first, and select deselect in case anything is selected. Let's select all, and then go to select, and select here object type, and the same process, we'll just go to select floors, and then select this, and then close. And after this, we'll go to assign, and we'll go and assign your shell loads, and in the form of uniform loads, I will just give a shell load in the form of your live load this time, and we'll assign a load of 2 kilonewton per meter square as gravity, that is from top to bottom, and then click on apply OK. So here, as you can see, this live load is displayed. So if you want to display live load here, as you can see, in the first floor, and the second floor, and also in the ground floor, this live load is there. And if you want to view the dead load in this frame, you'll just go here and go to display, and load assigns, let's say, your shell, and we'll select the dead loads, and then click on OK. Now the dead loads are displayed. So similarly, you can toggle between the dead load and the live load like this. So suppose I want to see the live loads in this particular span. I'll just click on this, and double click on this, and after that we'll just go to this display, and then load assigns, and then go to shell here, and suppose let's see the dead loads first, and click on OK. We're seeing the dead load here. And if you want to just display the live loads in the shell, we'll go to this display option, and then load assigns shell, and this go to live, and then click on OK. So the live loads are being shown here, and as you can see, this is 2 kilonewton which is being shown here. And if you want to display your particular wall load. This is the same process. Display load assigns, go to frame, date, and click on OK. The dead loads have been displayed. So like this, we can check all the loading. So now comes the explanation part, how we get this load, where and which portion of the IS code that these things are written. So for a reference, so we can just take a break and come back after the break. First of all, let us consider how the wall load acts. So suppose this is a wall, and typically we have a beam, and we know the way we have considered the floor to floor height of 3.2 meters. It's generally from the top of the bottom beam to the, up to the roof. So this height is your 3.2 meters. So typically you will find that the beam height for normal buildings up to G plus 2 is minimum 300 mm, or in this case we are taking as 0.35 mm. So, okay, so 0.35 meters, we are taking this as our height of this particular beam. So when this height becomes the beam, and the remaining height which remains, that is 3.2 minus 0.35 is equals to 2.85, which is available for the bricks. So this distance is 2.85 meters, which is available for our bricks. So the bricks which we are available in my place are 10-inch bricks or 9-inch bricks. So if you consider 9-inch bricks, then 1 inch will be plaster of total outer and inner. So I'm going to just erase this. So the initial data which you're going to write here for calculating the wall load is the wall height. Wall height equals to your 2.85 meters. So this will be the wall height which we will be considering. And the next thing which we will consider is our the unit weight. So the materials involved will be unit weight of brick or masonry. So masonry unit weight will check out from our IS 875 part 1, and unit weight of mortar, which will need this, which will also get from the IS 875 part 1. If your mortar is just the cement which is used to cement and sand paste which is used to fix the bricks or for the masonry works. And then we'll need the thickness of your masonry, and the thickness of plaster. You can say plaster or mortar. I'll just write mortar so that, because this is similar, I'll also include this thickness of mortar or plaster. So we know the thickness of the masonry here. It depends on the type of bricks. So if usually bricks, there are mostly 230 bricks are available. But in my place here, 9-inch bricks or 225 bricks are available here. So I'll just take this, and you can take as per your preference, or you can take this also for like a little bit extra. You can take thickness of mortar is generally 1 inch, considering 12 mm on the outside, and around it's generally 9 mm on the inside. So it depends, it varies. So on an average you can take this 0.025 meter or 1 inch for the plaster. And another data which you'll need is height of the parapet wall, which we'll need for the parapet wall load calculation. And this height of the parapet wall is 1 meter or 3 feet 3 inches. So this is by general taken so that anyone who is in the roof doesn't fall off. So this height is generally taken. So these two values will take, and after that we'll do the calculation. So what we'll do, we'll just move ahead to the IS code. So I am sharing the IS code here. So this is the IS 875 part 1, and in this IS 875 part 1, go below, and you can find here the table 1. So table 1 contains the unit weight. You can just download this from the internet, and it's easily available. And then you can mark the things which are necessary for you. Suppose I want to mark what is the unit weight of mortar first. So unit of mortar, we know it's around 20 kilonewton per meter cube, sorry. So we'll find it here, and also for the brick also we'll find it here. So we have blocks here, and we have, let's see what we have here. So here in this part we'll have the bricks, but you can do this common burnt clay bricks which you generally use. You can highlight this, okay, which you can use it later. So it is around 15 to 18.85. The the unit weight is rate is 15.7 to 18.85 kilonewton per meter cube. You can see meter cube here. Kilonewton meter cube is the unit weight of the bricks, and we can take it this approximately 19 to be safe. On the safer side we can take this, and this let's see the unit weight of the mortar. You can see it's cement, cast iron, and here I hope we'll find this ordinary cement. Yeah, here we have cement here, and what we want is cement. This reinforced concrete strength, as you can see, this is there. Okay, cement mortar or cement plaster you'll have here this 20.4. So 20.4 will take for the cement mortar, and we can take 19 20.4 from here, and we'll take the 19 for our red bricks which we have found here. 18.85 will take 19. So let's put this value here. So the unit weight of the masonry. So the unit weight of the masonry which is used here is 19 kilonewton per meter cube. So if you're using double AC block, this value is significantly less. It is around 7 or 8. So you can check this out from the internet. And if it's fly ash blocks, also you can check this from the internet. What is the unit weight of fly ash bricks, and then you can modify accordingly. So here 20.4 kilonewton per meter cube is this unit weight of mortar. Usually people take 20 on average. You can also take this also. So the load of outer wall or 10-inch outer wall. 10-inch means 250 mm. I'll just taking the load of the outer wall. So it will be the by the way, this thickness data is for the outer wall thickness of masonry. Here outer wall, the thickness of masonry will be the same, but uh, you know but with this placed differently. So this is the outer wall thickness. So outer wall will this first will take the height here 2.85 meter, and then we will take the thickness that is 0.225 meter. So it is in meter square already. Into will multiply by the unit weight. So the unit weight of mortar is your unit weight of brick is your 19. So we'll do 19 here. Sorry, it will be here. We'll do 19. This is in kilonewton per meter cube, and so the answer will be in kilonewton per meter square. So okay, we'll just do this together, and plus now for this for the bricks and then for the mortar. So this will be plus again the height. This is 2.85. I'll just copy this and we'll modify this thing values. So it will be your 2.85. The height will be the same, and the mortar thickness is 25 mm, and the mortar density or the unit weight is mortar unit weight is 20.4. So if we calculate this comes approximately just do the calculation, will come around 13 point something. So I have taken around 14 kilonewton per meter. So this is the load for the outer wall. Similarly for the 5-inch wall, everything will be the same. It will be approximately half, because load for the 5-inch wall, everything will be the same, only this thickness will change. So load for the 5-inch wall is 7 kilonewton per meter. So it will be half of the load of the your 10-inch wall. And now load of parapet, we have to calculate load of parapet wall. So parapet wall, generally we provide 10-inch parapet walls because for the safety purpose. So load of parapet wall also will calculate like this. And what are the values you will change? You already know this. So only the height will change here. Height will be your 1 meter, and here also 1 meter. So the value will come 4 point something, and I have taken it as your 5 kilonewton per meter. So like this, we have taken the load for the walls. Note, if you have double AC block, the load will be significantly reduced. We'll make a video on that later. So now for the floor finish, okay, for the floor finish. So floor finish, generally what we use are the tiles. Use tiles for the floor finish. So let's see what is the load we can take as per the IS code here. What the IS code says about the floor finish. Generally we know around 1 or 1.5 they are taken for the floor finish. So here in this table number 2, table number 1 is continuing here, and then below you will find the, let's see, I'll show you the location where to find the floor finish load. So we'll find the floor finish load approximately here, in page number 33 of the PDF when we'll download it. So here you'll find the clay floor tiles. Generally, the floor tiles thickness they have taken up to from 12.5 to 25.4 mm, and usually the mortar thickness is also around 1/4 inch. So mortar thickness is also there, 1/4 inch or half inch. So it adds, if you are giving a concrete floor, it can add up to 1 inch or 1.5 inch, depending upon the clay tiles thickness. So we'll take the tile thickness of suppose tile thickness is 1 inch or 25 mm, and the unit weight for it is 0.2 kilonewton per meter square. So this is 0.2 kilonewton per meter square, and you have to remember that this is only the tile weight, and it excludes grading. So we have to already include the weight of the mortar. So let's try and reach at a conclusion what should be the suitable floor finish load. And we also to remember that if you're considering the marble or something, the floor finish load will different. So we'll be a little bit on the safer side. Whatever the value will come, we'll take more. So equals to, we can take this 0.2 plus. Now the unit weight of mortar we all know 20.4, and we'll just multiply this 20.4 into, if we do suppose this 24.4 is in kilonewton per meter. So we'll just do this kilonewton per meter cube. Copy this here because it's important to know the things, and this is in kilonewton per meter square. So this is in kilonewton per meter square. This was already there in the IS code for the tile. Now we have to convert, this is for the mortar, so we have to convert this into your kilonewton per meter square. So we'll provide a thickness of half an inch. You can also provide 1/4 of an inch. So it will be 0.0125 meter. So the value will be 20.4 into 0.0125. This will be around 0.225. So 0.225 plus 0.2, it will be around 0.455. So the floor finish load is coming around this 0.455. So approximately we can just take this around 1 kilonewton per meter. So why? Because if suppose you apply marble or any other, if we suppose for the top terrace portion, there is the, this grading. So that also it will be, covered in this. So be on the safer side, we can consider 1 kilonewton per meter. So if this is a heavier material which are applying, then we need to change. Maximum this will be 1.5, but in 1 kilonewton per meter will be on the safer side in most cases. So it is not equal to, it is approximately equals to. So we are done through that, and after that what we need to know is our live load. Okay, so let's see for our live load here. For the live loads, we'll see our code of IS 875 part 2. So what IS 875 part 2 has done, it has taken the particular buildings and divided them into some categories. So the category which we are seeing here right now is residential buildings, And if you want to see the categories in detail, you will find here in this in this terminology two from, okay, not two, you'll find here in this 2 point, starting from 2.2, 2.2. So 2.2, occupancy or use group, they have classified the buildings into 8 types. So if you just read the suppose the if you want to know what you mean by assembly buildings, you're not familiar with that, you just read one or two examples, so you'll get to know that. Suppose theaters, motion picture halls, assembly halls, so these are city halls, marriage halls, so these are all assembly buildings. In the business buildings, you already know offices, banks, these are business buildings. And inside the business building, there is also a criteria for a office building. And there are the educational building, we already know, industrial buildings, the refineries, power plants, institutional building, which includes hospital, jails, mercantile buildings, which include wholesale or retail markets. Residential buildings, you already know. And in the residential building, there are only dwelling units, and so there can be apartment also. And there are storage buildings. So like this, there are buildings, or based on these buildings, the loads will be different, and which is mentioned specifically in the IS 875 part 2. So generally we'll need this for the residential building, it is 2. Suppose you're designing a cafeteria, then we have to search for, or suppose you're designing classroom, so you'll have to give a load of 3 kilonewton per meter square. And suppose you're designing a toilet or bathroom, there again it's 2. And there are various examples. Suppose if you're designing cafeteria, you'll have to give a load of 3. And in the case of assembly buildings, there are different. So for the different buildings, there are different. Mainly the range is between 2 to 5. 5 is the maximum in most cases. In mercantile building or wholesale shops, it is 6. So like this, you have to see what is the purpose of the building. So before making the structural design also, you have to know what is the purpose or the usage purpose of the building. So that's how you take the live load. So the live load is taken as per IS 875 part 2 table number 1, and it is 2 kilonewton per meter square for the residential building. And there is also another clause which you can see for corridors and for staircase, we can consider 3. So it is also mentioned here. You can see generally for the residential building it is 2, but for the balconies and for the corridors and passages, you can take 3. So this you have to know. So I suppose now we have covered all the basic aspects of Etabs, that is in the software, as well as the design concepts behind the assigning of our live loads and dead loads. So in the next video, we'll move forward and we'll assign our earthquake loads and wind loads. We'll do that, and also we'll proceed towards the load combination so that we can finish the loading part. So if you have learned something from this video, make sure you give a like in the video, and also drop me a heart in the comment section. This is your civil bro Mainak signing out. Bye bye, keep learning, and wherever you are, stay safe.